Okay, guys, hello everyone. I'm glad to see some faces here because I was afraid that because of this second day of the conference, the majority of you will be already gone. But there are some people, which is a good sign. Oh, I apologize for that. It was too fast. Before we get started, I have a question. How many of you works as a forensic investigators? Okay, there are some people, great. And how many of you is somehow involved into forensic? Maybe, I don't know, security operations center analysis or something. Okay, there are some people. Great, I'm asking because I have to know if I have to cover some basics, okay, to make sure that we're all on the same page, because that presentation will be for forensic investigators and everyone who is somehow involved in the forensic, okay? So we'll talk about the forensic artifact, which usually we use or we should use, okay? As you can see, if you're interested in what I do and in general about who am I, there should be a separate slide. I'm not representing any company today, okay? I'm just here as an independent researcher. And if you're interested in what I do, then I highly encourage you to follow me on LinkedIn, because every time when I create something, discover something, then I share it on my blog as an article, and then I release that information on my LinkedIn profile. And in terms of my experience, I have been working as a DFIR guy for the last several years. Mainly, I do forensic, malware analysis, and also reverse engineering. But generally speaking, I am focusing on forensic. So that's, of course, the reason why I'm here and why we'll talk about forensic artifacts. Actually, just the one. In our agenda, we have 6 different points. There is a lot to discuss, so sometimes maybe I will be, maybe too fast, but I will try to cover as much as I can, and then at the end, if there are any questions, hopefully we'll get time for that. As you can see, 6 different points. First, we'll try to cover UsnJrnl from, some basics, etc. What's that? Program execution. This is the core of the presentation. So if there is, if we have to choose one moment when you have to focus, then I would recommend that point. Program execution in the $.jn file. This is the most exciting part. Then after all, I will also show you how you can use that specific artifact to discover if and when file was downloaded via a browser. So without any logs from the browser, we'll just focus on UsnJrnl. Then one use case for the messaging app, and then we'll also try to review UsnJrnl without collecting anything from the machine. It's also quite interesting, and I will try to explain that in few slides. And then at the end, we'll jump to the conclusions, and I will show you what actually you should do in your organization on what should you recommend to your clients, right? Because I believe that some of you probably are in the internal SOC when you only care about your own environment, but probably also some people are working for clients. So we'll leave it at the end. UsnJrnl, this is of course our subject of the presentation, and a few words about that artifact. So for those who are not who don't work as forensic investigators, what we have to say that when there is a case, when there is the incident, we, as forensic investigators, we try to discover what was happening on the machine during the time of the infection, the breach, or whatever. Sometimes you are even investigating some suspicious people, right? They are doing something on the machine, you want to discover what they were doing. So when we are talking about the forensic, we try to utilize information that are available on the system for us, but they were never created for that purpose. Okay, so when I'm talking about UsnJrnl, don't believe that Microsoft created that for us to make our life easier. Definitely not, it's not the case. So as a community, we discover multiple different features on each operating system, which then we can parse and utilize during our investigation to build a timeline. This is what we call it, right? It's a timeline where we try to put all logs together, all events, and then discover what was happening on the system. And one of the artifacts, of course, is UsnJrnl, which was introduced in NTFS version 3.0, which of course appeared with Windows 2000. There are other file systems, so don't be confused with that. There is FAT, exFAT, FAT32. When we are talking about UsnJrnl, we are focusing just on NTFS, and that also means that we are talking about Windows operating systems. UsnJrnl, that's not the only one artifact which is available for us when we are talking about the NTFS. This is the first thing that we have to raise here. But when I talk to people who are doing some kind of forensic, and we talk about NTFS, then they always say MFT, master file table. Yeah, of course I use it. And I'm like, what about other artifacts, right? Are there any other artifacts? People are able to list few of them, but when we start digging deeper, they don't know how they can use it. Basically, people don't use that. And that's a mistake. And also, don't believe that I use all of them, which I listed here, right? That's not the case. But what I do, that usually I use MFT, a log file, and UsnJrnl. And today we'll only talk about UsnJrnl, and you may ask me the question, why this one, right? Because when you parse that artifact, you can actually discover multiple different things that took place on the system. Here we have information about all files modification that took place on the system. And now, usually when people are aware of that, they say, yeah, we can discover when a file was created and then a file was deleted, but actually I have EDR. I don't have to worry about that. That mistake. The majority of EDR products don't cover all file modification of the systems. Usually they do, and there are some, there are some logs. You're able to discover, yes, this file was created, this file was deleted, but for majority of our cases that I have, this is not enough. EDR is not enough. So you have to have a different way to prove what happened on the system. And now, when you're talking about UsnJrnl, don't think that there's just file creation and file deletion, because I observed that people like, yeah, I can discover when file was deleted and created, right, it's okay. But that's not everything. There is much, much more, and today we will try to check that operations. We will get, of course, to all that operation, because there's file creation, deletion, renaming, attribute changes, so you will see that in the moment. But before we jump further, I want to make sure that you know how you can do that in your own environment, or maybe for your clients. If you want to work with UsnJrnl, the best way is to collect that file. And this is a file which is created on the NTFS root partition. So, and this is how it is called, $UsnJrnl. But actually, if you want to see what's inside and you want to get logs, you have to collect two alternate data streams, which is called $max and $J. If you ask me the question, okay, which one I need? You need both, because the first one can be used to actually discover the configuration for UsnJrnl. You have to parse that file, and I will also show you how. And then in addition to that, there is $J file, and here I actually have the content of UsnJrnl. So you have to grab both files. And now you can ask the question, how can I do that? I will assume that if you are doing forensic, and you are making some kind of collection, then probably it's already included in the tool that you use to make a collection. If not, then one of the tools that you can use is the one that I'm presenting here. It's called FTK Imager. I don't recommend to use that tool in your environment, in your environment, right, when you're performing collection, because this is a GUI tool, and usually people don't recommend that, because every time when we have a GUI tool, then of course it utilizes more space in the memory and we're losing some information. So it's better to use a command line version of a similar tool. And now another question, why do I need that tool? Because that file is logged by the system. So you can't open Explorer and navigate to that path and copy the file. It will not work because it's logged by the system. So if you want to grab that file, you need to get a raw access to the disk, okay, or to the partition. And for that, one of the examples is that tool, FTK Imager. It's the old tool, and it used to be for free, and now, to be honest with you, I'm not even sure. What I did here is that I started the tool, I mounted the physical disk, then I chose the, I mounted the physical disk, and then I navigated to the partition for which I want to make a collection. Then I navigated to a root folder, because this is the one that you have to open. Then I'm listing actually a few of them, but what I need to open is the $extend. It's at the very beginning. And actually here you have extra files that you can collect. This is how I actually found UsnJrnl, and I also double-click on that to open that file. And inside, there are two, of course, there are three, but there are two alternate data streams that I need to collect, $J and $max. And then, of course, I exported them, safe on the desktop, and this is how actually I could start parsing them. Okay? Of course, here it was very fast. In the normal situation, it will take a little bit more time, but I use the magic of recording, right? And I speed up everything, and that's the reason why it was so fast. And now you can ask the question, okay, we have it, and can I just open that using Notepad++ or wherever? Well, you can use a hex editor, like, for example, 010, right? This is a hex editor like that, which you can use to open the file, and then there are even some templates which you can use to color all hex bytes, but that's not an effective approach. We need a parser. There are multiple different parsers available, even for free. There is even one parser created by Eric Zimmerman. Those who are working in forensic, probably you're aware of that. Here in that example, I use a different tool created by the guy who is called Pool Billionaire, UsnJrnl parser. This is a Python script, which you can modify in a very easy way. There are comments, and if you know Python, then it's not the case. But I prefer that one, it's relatively fast. And then in addition to that, you can modify the code and edit the output format. So what you need to do, of course, you have to download the archive from the GitHub repository, which I did here. I downloaded the archive. Then, of course, you have to extract it. Navigate to the folder, I think it's called USN. And this is something that you can find on GitHub, right, for free, so don't worry about that. Definitely a good tool. I really like that. And then inside there is a Python script that you have to run. This is, of course, a command line tool, right? I know that you know that, but I wanted to say it just in case. So I open CMD, and then, of course, I try to run it. The tool accepts 3 arguments. Our input file, so this is, of course, our $J file, then the output file, and then the format. In that case, I chose --CSV. It's up to you which one you will use. And then, in result, of course, the new file was created, and here you can see the size. It was 1.4 GB. And we'll get to that, and the UsnJrnl was actually about 2 GB, because I have modified the configuration, and we'll talk about that at the end. So yeah, once we parse it, we can see what's inside, because this is the only one way how we can actually extract that information from that file. And this is an example. At the very beginning, you have one entry from the new created file, and there are few fields which I highlighted. There is more, but you don't need to worry about all of them. That's the first thing. So actually, you need to be aware just of few of them, which is file name, operation, it's called reason, a bit mask indicating the reason for the change and human-readable interpretation of the reason bit mask. We'll get to that in the moment, so don't be surprised with that numbers and names. And then, of course, the timestamp, because when we build the timeline, what do we need? Timestamps. So with that, we have the time, when the file operation took place on the system, the name of the file, and the operation. There are many operations. And what I observe is that usually when I talk to someone about UsnJrnl, they'll say, like, file creation, file deletion. And like I said at the very beginning, that's true, but there is much more. I highlighted a few of them because personally I find them very useful, and in the upcoming few use cases, we will actually focus on them. So there is data override, data extend, data truncation. So as you can guess, yes, this operation indicates when the content of the file was modified in some way. Then another two, very useful, rename old name and rename new name. So if you're renaming or user or malware is renaming the file, then of course you have to focus on that operations, because they will, doing that you will discover when that operation took place, what was the old name, what was the new name, and I will show you why it is important. And here on the next slide, again, the same information, operation and reason. I try to group them, because this is how I see them, right? First, we have 3 operation indicating the modification of the content, and then 2 indicating that file was renamed. And this is a real example. So what I did is that on my machine, I created a new file. I right-click on my desktop, and I try to create a txt file. So system discovered that, and of course, made a track of that. That's the reason why we have the first 3 entries indicating that the new document txt was created. I didn't choose that name. This is like what my system did when I tried to create a new file with Notepad++. Then I renamed that file. So now, think about it, how it can be important during your investigation. When, for example, you try to discover like the initial file of the compromise, or maybe when data was staged and then the collection was renamed, wherever. So think about it. It's very important. Then I renamed that file manually, cyberdefner txt.txt. There are 2 extensions because I did a mistake when I was recording that, and I forgot that on my system that I was using, extensions are hidden. So you can also see that here. Then, going further, I renamed that again, and I put the name cyberdefner confidence txt, again, the same typo, and then at the end, I added the content. Right? So you can see it at the end, data extend, close. So this is actually the moment when I added something to that txt file. So now think about it, how it may be important when, for example, we are suspecting some data staging and data exfiltration. If you know when a file was created, when data was appended, and then you combine that information with, for example, your network logs and the activity that you observe on the system, let's say screenshot, right, a keylogger or info stealer that was making some screenshots, you can assess what potentially was exfiltrated, right? Of course, the forensic is about combining everything together and building one big timeline. So we do not rely only on one artifact. We combine all information together, and then we can conclude what happened on the system. And now I promise you that we'll use that artifact to prove program execution, and I didn't lie. Those who do forensic You may ask if maybe some of you do that, and that's amazing, but let's think which artifact on Windows operating system is updated every time when we launch the binary. I mean, what forensic artifact is modified when you run an executable? Is there any artifact that will be modified every time when you run an executable? Prefetch file, exactly. So now, I tested a few things. So those who are not aware, prefetch file, this is of course the artifact that we have on Windows operating system, which is created when you run the executable, and then every time when you run that executable, it's updated. And in the result, we have up to 8 timestamps, last execution times plus creation time of the prefetch file. So just to make it clear, when you run, for example, word.exe, then the prefetch file for that executable will be created, okay? And now we can parse it. We discover as a community of forensic investigators, someone discovered that actually we can parse that information and extract that data from that file. In addition to that, we have total run count, path to the loaded DLLs, a lot of different information. If you talk or interview anyone who is doing forensic, and you ask him a question, what is the most important and well-known artifact proving program execution? The answer is always prefetch file. But what I have observed that there is a big problem with that artifact, especially with the latest version of Windows operating system. Because indeed, that file is created, but very often it's deleted. So I think that some of you may observe that when you're performing your investigation, you grab the entire folder where you have prefetch files, you parse it, and then actually you're seeing that the prefetch entry for the malicious file is missing, because it has been already removed by the system when the system was defragmenting the disk. So here I did a test. When I was preparing the presentation, the slides for that presentation, I created an executable which was called cyberdefadmin or whatever.exe, and I ran it from one place, then I copied that file, ran it from a different place, because the prefetch file is for the executable, and then as you can see, oh my God, the square in red, there is a hash calculated using the name of the file and the path. So if you have 2 prefetch files with a different hash at the end for the same executable, then it means that actually it was started from 2 different places. We can't confirm actually in 100% that this is the same executable, but it may be a good assumption. So first, I ran it from different places, and then after a few days, I tried to work with the prefetch again. Of course, I did it because I knew how it behaves. But here I wanted to prove that indeed this is how it works. And then, 2 days later, or 3 days later, I checked prefetch files again. And what happened? Some prefetch files were missing. So, moving further, when I parse, this is the output which I got using the UsnJrnl tool, which allows me to parse prefetch files. When I parse the file, this is the output which I got. What do we have here? We have the last runtime and other runtimes, where we have 2, so in total we have 3 different runtimes. When I was parsing that prefetch file, actually in total there were 22 executions of the same executable. And that was not here. So if I just grab that file and parse it, I would say, yeah, 3 times. The malware was started 3 times. It's completely incorrect, because actually previous version of that file were deleted from the system. So finally, we are getting to our main subject, UsnJrnl. So having that information, having the knowledge how prefetch files behave, I parsed UsnJrnl. And then I try to search, first of all, I try to search how many times, first I try to check all unique names for my executable. In results, I discovered that there are 3 different files. When I was making collection, there was just 1 prefetch file. So 2 were missing. And even the one that I grabbed had a misleading information. So going further, if you think about it, we can actually use UsnJrnl to discover all execution of the file without even grabbing prefetch files, right? And this is where I did a search, and I wanted to see, I tried to list it, all events indicating that prefetch file for cyberdefadmin was created and deleted, okay? I didn't care about the path. I wanted to discover all execution of that file, because in a normal situation, when you have the user who downloaded some malware, then I don't know, maybe it was saved in the download folder, then it was moved to desktop or wherever, right? I wanted to have all that logs. So what I discovered is that at the very beginning, the same executable, well, assume that it was the same executable, at least with the same name, was executed from 2 different places. And this is, you can see, I try to distinguish them using different colors. But then, both of them were deleted. They were deleted actually after 10 hours. So now imagine the situation that you have an incident, you make a collection 2 days later. You know, of course, it depends on your reaction and if it's for client, but still, 10 hours and everything was missing, right? So my system actually deleted the well-known artifact for program execution, and I couldn't use that. And the same happened with the third file, and then finally, that was 14th of May, I ran it again, and the last version of that file was created, and this is actually the one which I parsed a few slides before. So now, having all that information, I discovered that actually I can first identify the name of each prefetch file, and then I can discover, well, of course, creation, that's the first thing, and then I can actually focus on these 3 operations, which I listed, a few slides earlier, right? So data truncation, extend, data truncation, and then extend, data truncation close. Yeah, it's quite confusing. You just have to remember which one you have to grab, or you have to filter out. And doing that, I was able to discover our execution, because to be honest with you, every time when I was executing that file on my machine, I was making a note of the time when I was actually running that, just to keep a track of it. So then this is how I group them together, right? And I discover, in total, 22 executions, and everything made sense, right? This is actually the real time, this is the real information indicating how many times this executable was created. So in the normal situation, imagine the situation that, I don't know, you're using an EDR that allows you to make a collection, you connect to that machine, you run your tool, you grab the prefetch file, and then your management or anyone who's, coordinator or incident, manager, wherever, ask you a question. Did you parse prefetch files? Yes, I did. Did you discover how many times the file was executed? Yes, I did. How many? 2, 3. Yeah? But that may be completely incorrect. Because then if you take a look at the UsnJrnl, you will discover, oh, I was incorrect. There is much, much more, right? So this is something that I have been using for the last few years, and it works pretty well. I don't even worry about prefetch files. Of course, there is a specific reason why you want to parse prefetch files, because you want to discover what DLLs were loaded, what other files were loaded by the executable. So that's the reason why, of course, yeah, it's nice to parse it. And in general speaking, I'm saying the same thing. Parse everything that you have, right? You have to collect everything, and you parse everything just in case. But actually, I prefer to rely on UsnJrnl because it has much more information. Okay, and that was the first use case, which for me is like the most exciting. But that's not the only one thing that I discovered when I was working with UsnJrnl. There is another scenario that actually, using UsnJrnl, you can discover that file, your malicious file, that you identify, or maybe EDR reported some malicious file, you can discover and prove that it was created using the browser. Of course, you may ask the question, why should I care about it? I can ask the user, I can parse browser history. Well, theoretically you can, but there are always the situations and scenarios when maybe user deleted the entire browser history, or maybe you was using a browser in the incognito mode, or maybe you just don't have that database, right? Very often, collection is automated, or maybe it's provided by your client, and I don't know, there were different profiles for the specific browser, and you don't have that history, right? What then? You have to have a different way to prove that, yes, this file was downloaded by the user. Maybe he didn't even, maybe even he did it on purpose, who knows? But first we have to prove that, yes, this file was downloaded via browser. So using UsnJrnl, I discovered the way that actually I can also prove that. I tested different browsers, Opera, Firefox, and then Microsoft Edge, Comodo, Vivaldi, and Chrome. Of course, last 4 browsers are using the same engine, Chromium-based browsers, right? So it's actually the same thing. And the behavior for last 4 browsers was exactly the same. So simply saying, I focus on 3 different browsers. I started with Opera, and I tried to grab a file using Opera, and I wanted to see how system tracks that, because that was my goal. And what I discovered, and just to clarify, now when we're looking at the logs, at the end of each entry, there is a number. And that number, this is a reference number for the file, right? So this is the same number that you can, for example, find when you're reviewing MFT. So you need that number if you want to actually find all operations for the specific file. You can't just rely on the file name because user can rename the file, a system can rename the file. So at the very beginning of our investigation, when you're suspecting that, yeah, this is my file, this is like the root cause or data, you know, wherever, it doesn't matter. If you have the name of the file, you have to make a search for that file and identify the ID, the reference number. And now we stop using the file, the name of the file. We don't care about it anymore because it's not reliable information. We care about the reference number. And this is at the end of each line. And what I did, so I downloaded the file which was called image1.jpg, right? I downloaded the JPEG file. I did a search for that name. What I discovered is that I discovered two different reference numbers. The one highlighted in orange and one in blue. And then, using the first reference number, that one highlighted in orange, I did a search. And what I discovered is that first, my system created a TMP file, that one at the very beginning, which is highlighted in green. Then going further, the system or the browser created another file. That was just a link file, so I wouldn't worry about that one. So there was a creation of the file using the target name, and then it was renamed to LNK file. But what I really care about is that first TMP file, because after that, the TMP file was renamed, and it was renamed using a target name and the extension that you can see here on the slide, OP download. This is like the critical information when you are talking about the Opera, and then after that, it was renamed again using the target name, the name of the executable which I chose. So think about it, and this is that happens it happened every time when I was downloading the file. So looking at that, actually we're able to discover the specific sequence of events that allows us to prove that the file was downloading using that specific browser. First, we have a creation of the TMP file. Then, of course, in the middle, we have the creation of the link file. We don't worry about that one. And then after all, previously created TMP file is renamed using that extension OP download. And then we have finally, again, another event indicating that the file was renamed using a destination name. And what's interesting is that some EDRs also see that modifications. So I don't know what EDR you use, but sometimes you may be able to discover the same sequence of events just looking at EDR logs. And this is quite interesting. So we don't even need to use UsnJrnl, but if you have UsnJrnl, then of course you can parse everything and observe the pattern. This is the pattern which I observed for Opera, but then I didn't give up and I jumped to Firefox. With Firefox, the situation was different. Actually, 3 different files were created, but it always looked the same. That first it was creation of the file using the name which I chose. Then it was renamed using that automatic destination-ms file. Then after that, there was a creation of the link file. So again, I don't care about the link file too much. And then finally, there was a creation of the file using a target name. And sample saying, this is it. So every time for Firefox, the situation was exactly the same. So if I'm suspecting that if I have a file, I identify the reference number, and then I check the history in UsnJrnl, and bam, I have actually our sequence of events, which indicates that, yes, it was downloaded using Firefox. For Firefox and Opera, of course, the situation is easy because usually there's one instance of Firefox and one instance of Opera. With Chromium-based browsers, the situation is a little bit more complicated because, and this is, of course, the graph illustrating the sequence of events for Firefox, right? Using different colors, I try to identify that actually 3 different files were created and just one of them was renamed. And for Edge, there is one issue that you can prove that it was downloaded using a Chromium-based browser because there is the extension, so the same situation. TMP, this very similar situation that we saw with Opera, creation of the TMP file, then the file is renamed using the extension CR download, and then again, it's renamed using the target name of the file, okay? So this is how it looks, and now the question, so which actually browser was used? I don't know, maybe it was Edge, maybe it was Chrome. Unfortunately here it's hard to say, but still we know that the browser was used and we know the engine. So if you parse other artifacts, then you will discover which browser is installed, and if there is one, then you know which one was used. And the point here is that actually sometimes we may not even care which browser was used, because who cares which browser was used, right? We want to prove that, yes, user downloaded that file in some way, maybe on purpose, or maybe, they didn't know what they were doing. It's hard to say, but at least we know how that system, we have the root cause, right? And this is something that you always want to discover at the beginning of your investigation. And here there is a graph illustrating the sequence of events for Edge. And like I said, all Chromium-based browsers behave the same way. They always create a file with a CRD download suffix. So quite misleading, but actually it's still good enough. We don't have to worry about that part too much. And there is another use case which I also discover, and I find that really useful because you can again identify the reference ID for the file, and then you can prove that it was downloaded using the instant messaging app. I discovered that pattern for one application, and it was Zoom. So it behaved like, like Opera and Chrome, a little bit. The sequence of events was slightly different, but in that case, I downloaded the archive, which I transferred to myself using Zoom from different machine. So I sent a file to my second machine, and I tried to grab that file. And it was called cyberdevnerd.zip. And what happened on the system is that first, the file was created, and then it was renamed to a link file. Okay, so that was just a creation of the link file for that archive. And then after all, system created one more file, which was named using the destination name, the target name which I chose, and then appended that suffix, ZM download. So, and then after all, it was renamed using the target name. So again, another use case where actually you can use UsnJrnl to prove that file was downloaded by the user, but this time using Zoom. Right, so it's very important information, especially when you don't have all logs and you still don't know how actually user downloaded the file and how that infection started. And here there is a graph illustrating the sequence of events like I did for other browsers, right? Just to make it a little bit cleaner for me. And now there is another quite interesting topic. At the very beginning, I told you that if you want to work with UsnJrnl, then of course, yes, you have to make a collection, you have to grab the file, parse it, etc. Sometimes it may be complicated, especially if there is no way to transfer that file from the suspected device. I don't know, maybe you're working with server, or there is a workstation and the connection to that machine is quite poor, right? And they may be the reason when you're not able to make a collection. Then actually, there is a way to do that using a built-in tool. So this is a tool, you don't need to transfer anything to the machine that you're investigating. There is a tool which is called FSU tool, and that tool can be used for multiple different things. And one of the arguments that you can provide, of course, it's UsnJrnl that allows you to manage USN on the system. And then the command will be FSU tool USN, and here, as you can see, there are 7, if I'm not wrong, different options, different arguments that you can specify. The first two, I think that they're self-explanatory, so you can use that tool to actually create the UsnJrnl on your system, or actually, well, usually it will be created, right? But you can use that command to modify the size of the UsnJrnl. And in that case, yes, it's very helpful command, and we'll get to that. I think it's the last slide of the presentation. You can also delete the UsnJrnl. So this is something that actually you can create a rule for that with your EDR. Because if you review my tree attack framework, you will discover that this is one of the techniques which threat actors can use to cover tracks. They can delete the UsnJrnl, and then, of course, you will not get any logs. And there are 4 other options. I will ignore the one which is called enable range tracking. But then we have enum data, query journal, read journal, and read data. The names are a little bit confusing. Some time ago, I wrote an article actually about that one because I tried to summarize each argument and understand how it works. So if my presentation is not clear, then I refer you to the article that you can find on my blog, because there I try to test everything and describe in the nice way. But okay, here is the same slide, sorry. So here I just tried to highlight the first 2 comments for creation and deletion, and then of course you have enum data, query journal, read data, read journal. And then the first one, which is very interesting, is FSU tool USN query journal, and then you have to specify the partition that you want to review. And simply saying that will give you the information about the maximum size. You need that size if you want to assess how many logs you can find inside, right? Because the size is like the most important factor here. When the size is bigger, then of course you can get more information. And the same information about the maximum size you can get from the first file that I showed you at the very beginning, $max. I will show you how you can parse it, but if you're making a live analysis, then you can run this command and then you immediately have the information, okay, what's the maximum size? In that case, it was 2 GB because I modify my system. And then, very useful command, it's actually UsnJrnl. That allows you to get the same information that you would get if you parse the UsnJrnl, but actually you don't need to transfer that file. I used that command several times in my investigations, and I was able to actually extract all file modifications, all logs from the system just running that one command, and then as you can see, I try to pipe the output to a new file. And then you would have a CSV file which you can just transfer. And it's quite useful because sometimes if you try to grab UsnJrnl, the size of the collection may be very big because the system actually may allocate much more space if it's actually needed. Then when you try to transfer that file, the size actually is much bigger, but actually the majority of it can be just full of null bytes. With that, you will actually get a similar output which you would get if you just parse UsnJrnl, right? And you don't need to pipe that to a file. If you know the name of the file that you try to investigate, you can of course pipe it to a different command like find string -i and then /i, and then you can use the name of the file that you want to find. So very useful and definitely something that you should be aware. Then another command, that command read data. This one may be confusing, so probably after all it's just better to read the documentation, make sure that you really understand that. With that command you can get the basic information about the file that you are trying to investigate. In that case I did a search for cyberdefner-admin.exe. This is the executable which I run, and I wanted to identify the USN number for that file and then the file reference. Because actually, so first of all, I proved that that file was available on the machine at some time. Right? Maybe it's no longer available in MFT. Maybe you tried to check that, maybe you tried to get that file from the system, you couldn't find that. But actually doing that search without transferring any tools, I was able to prove that yes, this file was available on that machine, right? And once you have the file reference number and the USN number, you can get that information and did another search using FSU tool enum data. This is like the most confusing tool, at least for me. The argument, because it takes few arguments, okay? First of all, you have to specify the USN the reference number for the file that you're investigating. Then you have to provide the USN. So first you have the reference number, then you have the USN number for that file, and then after all, in that case, it will be, let me read, it's the number which ends with AFFF. Here we are defining the scope of the USN entries which we want to review. So, I made up that number. I just increased the USN number for the file that I found and increased that with FFF at the end just to, extend the scope of my search, because I wanted to see if there are other files that were created, modified, or whatever on the system when that file was created. And doing the search, as you can see first, there are the information for cyberdefner-admin new.exe. So this is the moment when the executable was modified on the system. And then 2 entries later, you have a prefetch file. So actually, I know, without parsing anything, without any EDR logs, nothing like that, I know that the file was created, and then almost immediately after that, it was executed, right? That would be all in terms of use cases, and now I think that the most important information extended to UsnJrnl. So everything that I showed you, those who are responsible for forensic, I think that you will find that useful, or maybe it's already something that you were doing. But there is one issue. The default size for UsnJrnl is 32 MB. It's not enough, because usually it covers 1, maybe 2 days. So if you're quick enough, then yes, you can use that and extract some extra information. But what I highly and that information can be retrieved from the $max file, okay? And if you want to parse it, then, for example, I created one parser, and you just provide the path to that file, and in the results, you will get the information about the maximum size of the UsnJrnl. But if you want to change the size of that file, of that artifact, then you can use that command, fsutil usn query journal. Okay, so here we are actually, first we are trying to get the information, what's the maximum size, and then with the second option, an argument m, here we specify the new size. And now the most important question, and here you have a comparison actually of this, how it looked like before the change, like max USN is FFFF0, and then after, did I take a wrong screenshot? Oh no, maximum size is 80000, and before it was 2000. Okay, it's good. And now the most important thing here is that I created that presentation because I wanted to encourage you that actually that change doesn't cost you anything. Think about it. This is just the size of on your storage. Is it expensive? It's not, because these days storage is very cheap, so it's not expensive. But your time is expensive, especially when you're working for your clients, right? You want to, take a case, grab everything, parse, and then discover, yeah, this is what happened, bam, another case, right? Or maybe a time for a coffee. So it's a very good idea to modify the default size of UsnJrnl in your environment or for your clients. Because like I said, it doesn't cost anything. You may ask the question, so what would be the good size? It's hard to say, because it depends on the infrastructure. If workstations are very busy, then of course the size, because you have to remember that it rotates, right? So the UsnJrnl will rotate. If there is a new event and there is not enough space, then it will delete the last entry. So I would test it, how it behaves and how busy your systems are. But if you don't know how to start, I would say maybe 2, 3 gigabytes. Is it a lot? It's not. It's how many, it's almost nothing. But actually, I would say on that system, the maximum size of UsnJrnl was around 2 gigabytes. And I had records for last 2 months. But this is not the machine that I use quite frequently. Usually my wife uses that machine, right? So some, Facebooks, etc., not much. But 2, 3, 4 gigabytes is a definitely good number. So yeah, with that, that's everything. I hope that you found that useful, and if there is anything that you should remember after that presentation, or if there is one thing that you would like to remember, is that actually it's a very powerful artifact. But you have to adjust your systems, yeah? And then you can extract a lot of information. So yeah, that will be everything from my side. Are there any questions? I'm guessing that yeah?